Hello, everyone, and welcome to another complimentary Green Tech Media webinar. Today's webinar is part of a series of webinars we do throughout the year to help keep professionals in the solar industry informed through research and analysis on the latest technologies and market trends. Today's presentation, Advancing Utility Scale Solar to 1500 volts and beyond, is brought to you by GTM Research. During today's webinar, we'll hear from Dan Shugar, founder and CEO of NEXTracker, and Stephen Jones, Director of Solar Operations at Blattner Energy. I'm Ben Gallagher, an analyst with GTM Research, and I'll be moderating today's webinar. Green Tech Media delivers business-to-business news, market analysis, and conferences that inform and connect players in the global clean tech energy market. Our coverage extends across the clean energy industry with a focus on solar power and the electric utility market's evolution. GTM Research is the market analysis and consulting arm of Green Tech Media. You can stay informed by reading the news on greentechmedia.com and find out more about our research by visiting gtmresearch.com. Before we get started, I'd like to take a moment to go over the screen in front of you. You'll notice several widgets at the bottom of the screen that may be of interest to you during today's webinar. The green folder contains a link to download a copy of the slides from today's webinar. You can also share this webinar through your preferred social media channels by clicking on the Share widget. Speaker bios are accessible through the blue widget next to the GTM logo. Most importantly, please note the Q&A module on the left side of your screen. At any time during today's presentation, you can submit your questions for our speakers. We will be answering your questions throughout the presentation today, and we'll also have about 10 to 15 minutes of Q&A at the end of the presentation. And with that, 2016 is slated to be the biggest year ever for solar in the United States, with over 14 gigawatts installed by year's end. The engine for much of this growth is the utility scale market. Utility solar will make up nearly 2/3 of all PV installations this year, with almost 10.5 gigawatts installed. With the extension of the ITC, an additional 20 gigawatts of utility scale solar will be installed between 2017 and 2020. Historically, a few states have made up the majority of utility PV installations. This includes states like California, Arizona, and North Carolina. However, with this year's utility scale PV project pipeline at an all-time high, the market is beginning to truly diversify geographically. At present, there are 11 states with over 500 megawatts of PV projects in development, and a total of over 20 states with 200 megawatts or more under development. One of the key factors for this geographic growth is the dramatic costs and price reductions for utility scale solar. From just the first half of 2016 to the second half, utility project EPC turnkey prices have fallen by over 16%. While price declines for modules spurred much of this drop, one major lever for this decline has been the adoption of 1500 volt system architectures. For more, we'll let NEXTracker and Blattner talk about how we got here, why 1500 volts, and where the industry is going. And with that, I will hand it off to Dan.
Thank you, Ben. Really appreciate the invitation of GTM to present this webinar. And it's really an honor to be doing this together with Stephen Jones at Blattner, a real leader in utility renewable energy EPC work. NEXTracker is a Flex company. We merged with Flex, formerly known as Flextronics, about 15 months ago. And our company had been growing really nicely. Folks were asking us then, why did we want to do the merger? And what we had seen is, this growth in the size of these systems. When early in our careers we were doing kilowatts and then megawatts, now gigawatts. Some of these plants are valued at over $500 million. And so we wanted to be able to really have a global presence and reach, be able to go to places that are hard to do business, and also have a parent with enough wherewithal to deliver that. And so we actually went ahead and did this merger about 15 months ago, and it's worked out really well. So let me introduce Flex, our parent company, in this next slide. A lot of folks have never heard of them because they're actually a manufacturer for, in many cases, other brands. But this is a $26 billion company. Its headquarters in San Jose with 200,000 people, 100 manufacturing sites in 30 offices in 30 countries around the world. With deep work in energy, making a significant portion of U.S. utility meters for utility clients, having manufactured over 10 million microinverters, 2 gigawatts of module annualized production capacity. So this is a really big company. Flex is publicly traded on the NASDAQ. They reached investment grade, which is a really big deal, over a year ago, and they throw off hundreds of millions of dollars a year of free cash flow every year. So we thought it was important as the industry, and particularly on the utility scale side, came to such a large scale that customers had confidence that their partner that was making the backbone of their system would be around. And so this has worked really well for us and also helped us expand geographically where in places that are otherwise difficult to do business. For example, in India, we just delivered the largest tracker in India, which is running with our customer Adani. And Flex has over 10,000 people in India, so we were able to integrate our much smaller team into their team using their legal entity and be able to serve that clients in that geography. And so we see this sort of as a trend for now that our industries just the growth has been astonishing. What Ben showed in the U.S. is mirrored around the world, and now we really think solar is moving more to a manufacturing model, as other industries like automotive and other industries have shown over time, versus a vertical integration model. Okay, let's talk about NEXTracker a little bit. We are the #1 global supplier, and GTM published a great report on that earlier this year. We've delivered about 5.5 gigawatts since 2004, and have in total over 150 projects that are delivered and operating. We've never had a legal action. We've never prevented a client. We've always supported our clients to make sure they hit their completion dates on schedule. And every project that we've set out to do with a client has been successfully financed. And when projects run into challenges, we're working with a client right now that dealt with some pretty serious weather conditions, slowing their project down. We mobilize, we provide a lot of support. So our DNA is really in the project side and helping clients achieve their objectives. And we're pleased to be on this, sharing this webinar today with Blattner. We have over a gigawatt delivered with Blattner at 1,500 volts. A lot of folks have talked about it, but with Blattner, we've been able to walk the walk. I want to take an opportunity and speak a little about trackers. I'm a tracker geek. I've been carrying the tracker flag as an evangelist, actually since the 80s when I had the privilege of working at PG&E. We had done some analysis back then and determined that trackers were the way to go, and horizontal tracking was the most cost-effective flavor of tracking back then, and had the privilege to do a project which, believe it or not, was actually, I think, the largest project done in North America in the decade of the 90s, and it was a whopping 0.6 megawatts. And this was part of the National Test Project at the PVUSA site in Davis, California with U.S. with DOE and a bunch of utilities. And so actually on this one, it was horizontal tracking. And we actually did individual rows, working with our partner, Arco Solar and Siemens Solar at that time. And then we got involved with really commercializing trackers. We analyzed it, and we actually developed and commercialized linked row tracking, starting in the late 90s. And going through in 2004, we did the world's first 10 megawatt project. This is when I was president of Powerlight, and later we merged with SunPower, and then proceeded to be the largest system in the U.S. for a number of years, also horizontal tracking, 14 megawatts at the Nellis Air Force Base, and culminating with a 300 megawatt project in San Luis Obispo. And so all these projects were linked row systems. We built about 300 or 400 systems. I was also responsible as president of Powerlight and SunPower for global O&M. And so I'm going to come back to these and how that relates to voltage a little later in the presentation. So then at NEXTracker, we launched this company, and we thought a lot about our previous experience with those other technologies, and those systems worked. The linked row systems, somewhat like a Venetian blind. There's one mechanical unit that moves half a football field or a football field with solar panels. They work, but a number of constraints came with them. And so we wanted to reimagine the tracker. And when I sat down with our team, I said, any design, we'll entertain any design as long as it's independent row design. Because what the long-term operation had showed us was that we wanted the flexibility to be able to move the rows around on site during design and construction, but also the top O&M considerations were washing panels and vegetation management. So we wanted to be able to facilitate that. And that's also going to help us on this 1500 volt thing. So we launched here in 2013 and 14 with a small project in California. We moved down into Latin America with a couple larger projects, 73, 69 megawatts in Chile, and then continued geographically in Australia with the largest tracker there in Moree, Central America, an 80 megawatt tracker, and then started doing larger systems in California, moving up to Utah with a 400 megawatt project completed earlier this year, and India's largest project, 105 megawatt system. And then basically the reason we were able to achieve this rapid market growth is that we brought a lot of new technologies to the table that delivered real benefits to customers and projects through both lower levelized cost of energy in the panel, faster construction, in many cases with lower initial costs. So customers sort of have the best of all worlds, lower cost, faster installation, more energy production. So we introduced the long row tracker with the 80 module tracker. And this was possible. Previously, there were mostly 40 rows trackers that were out, 40 module row trackers that were out. Where this was possible by moving to a balanced design where the center of mass is in line with the rotational plane, which allowed less piers to be installed per megawatt, a higher degree of rotation angle with 120 degree rotational arc, and 15 degree slope tolerance. And the design incorporated torsional limiters to prevent the tracker from over-rotating at each pier, so only 8 panels of wind force can be accumulated before that is transmitted into the ground. And so this is going to help us on the 1500 volt design when we get to that in the next slide. We also introduced the self-grounded tracker, where the tracker itself is the grounding element. And so this structure is listed to Laboratory Underwriter Code 2703, and this just reduced the amount of electrical material and labor required to have the system compliant with code. We introduced 2 years ago the self-power tracker, So the entire tracker is powered by a small solar panel, and that's actually pictured here in the center. There's a very small panel compared to the larger panels which are actually making power. This eliminated the need to run AC power out to the field, surge protection, conduit, disconnect switches, transformers. This really sped installation and also enabled, we manufacture a controller with our parent company Flex on the same kind of lines that make medical devices, telecommunications equipment, satellite equipment, and so forth. So very high quality from our parent there. And these controllers have integrated a small UPS system, so we can always command and control the systems independent of whether there's power to the site or not. And integrated with each one of these rows, every single row for every system we've delivered everywhere in the world has the capability to, in real time, monitor the angle through an integrated inclinometer and report on that through wireless communications with the Zigbee wireless mesh network system, which was made prevalent in utility smart metering. And so that information really allows us to deploy the predictive analytics and digital O&M, which we rolled out last year, for allowing auto commissioning for really rapid commissioning, remote monitoring control, and then characterization of electrical and mechanical system health. For example, if a site has soil conditions that are suboptimal and a pier began to differentially settle with respect to the other piers, we would detect over a long period of time, we detect higher motor current to move that particular tracker, and then O&M can be rifle targeted to that particular issue. Okay, so that's kind of how we got here. Now, about 18 months ago, we had the incredible privilege to start working with Blattner, and we had a portfolio of clients that really needed to get to the next level for cost and for both installation costs and O&M cost, as well as more energy production. And so we really took a step back together and tried to find a way to deliver the 1500 volt systems. And so at this point, it's my privilege to introduce Stephen Jones, who runs solar for Blattner, and take it away, Stephen.
Great. Thank you, Dan. Welcome, everyone, to the webinar. Again, as Dan reiterated, GTM does a great job in arranging and making all this happen, so hats off to them. My name is Stephen Jones. I am currently the director of our solar operations at Blattner Energy. I've been with the company approximately 16 years and been in the renewable energy market for all 16 of those years at Blattner. Also on the phone supporting us is Kurt Polzak, and Kurt leads our engineering group at Blattner, so if there's questions that you all have with respect to the technology or the engineering, Kurt certainly would be answering those. So I'll just take a few minutes just to walk through who we are and really what we do. The Blattner family company was founded in 1907 and employs approximately 3,500 people nationwide. We're currently in our fourth generation of family leadership at the company, which is certainly an honor for us to be working with a company that started well over 100 years ago. Blattner Energy's business model is certainly structured solely around the energy business, serving the wind, the solar, and the power delivery markets. And being in the business 30 plus years, really our core competency is taking, a client's concept of a power generation, whether it be 50 or 100 or 1,000 megawatts, and executing that, constructing it into an operating generation plant, along with certainly building out the interconnect and the transmission infrastructure to carry that power out to the grid. So we currently have approximately 32 gigawatts of renewable energy experience, with 2 gigawatts of that being specific to solar. So as we take a project from concept to a point of, I think, online and interconnected into the grid, our company manages and performs all facets, from the project feasibility stage to the point of commercially online. That's a fairly long process, and I think what makes Blattner unique is that we have the core capabilities in-house to self-perform the majority of those responsibilities through the project life cycle. Because we manage, execute, and control all of these stages, as you see, of the project, it certainly brings an advantage to our clients, to their projects, and certainly has allowed us to bring 32 gigawatts of projects online without missing a COD. So one thing that we have all in common, I think, on this call is, we've seen the solar industry, as Dan said, walked us through the evolution here. We've seen it evolve very rapidly. In my 16 years in the business, I've never witnessed such a rapid transition year to year in an industry. So there are many we could talk about, but the one that we really wanted to discuss was the evolution from 600 to 1,000, and really now, as we all look at this, now we're at 1,500 and 1,500 volt solar systems. So I'm going to hand this back over to Dan, and he'll walk us through the migration so that we get to the heart of the why. Dan?
Thank you, Stephen. Okay, let's take a step back and look at the evolution from up the voltage curve. So, when we were doing systems back in the 80s and early 90s, everything was 600 volts, whether they were utility scale or not. And we've kind of listed out how the code evolved, starting with the first edition of UL 1703 in 1986. And as that code has evolved and come up through, and then talked about, sort of contextualize the 600 volt era, which was down below. So all the projects we were involved with in the 80s and 90s were 600 volts in the States. Now what happened is, because we got involved in Europe in early 2000, it was in 2004 when I was with Powerlight, we built the world's first 10 megawatt project. And that was also a horizontal tracker, a link to our tracker actually, and we built that at 1,000 volts. And so being able to operate, and we really owe Europe a lot of credit for driving the high voltage systems. They have a lot of it came actually from the train industry and locomotive technology. And so we were building the system and really seeing the advantages of doing that over in Germany and thinking, gee, we really should bring this to the U.S. And so in 2007, we did this Nellis Air Force Base project, and we drove that to 1,000 volts. That was, if not the first, one of the first 1,000 volt systems in the U.S. And we sort of started differentiating with our clients, hey, this is kind of a behind the fence project. It's, and then worked with manufacturers, to get the module technology and the encapsulant materials and the inverter technology to be compliant with that. And so we really saw a lot of benefits by going from 1,000 to 600 on the electrical side, and Stephen's going to go deep on what those are. And then, again, Europe was really leading the way. We started seeing these 1,500 volt systems coming in Germany in 2012. The NEC was catching up, and First Solar actually installed what we believe was the first 1,500 volt system in the U.S. in 2014 as the very first project. So then we collaborated with Blattner and a number of clients to really, really drive this and get this done on a tracker. And we'll show you some of those details now. So one thing that's super critical when you're thinking about a tracker or other structure is co-optimizing the electrical and the mechanical elements together. And so in the case of the 1,000-volt trackers we had developed for warmer temperature climates, those are typically 80 modules, if we're talking crystalline, of 20 modules per string and 4 strings per tracker. And so we had earlier in the presentation spoken to introducing that super long 80 module tracker. Well, here when we started thinking about 1,500 volts, we saw there was an opportunity to take it even further. Because our system was balanced mechanically, we were able to push that to 84, 87, or actually 90 modules per tracker by going to strings of 28, 29, or 30. And there'd be 3 electrical strings per tracker. It's important not to split the strings between adjacent trackers for construction considerations and yield issues. And so we conceptualized this, and this thing's long. I mean, you're talking about almost as long as a football field on there. And in addition to supporting the 1,500 volts, it also results in a lower cost tracker because you're amortizing the cost of the drive system over more solar panels. There are quite a few electrical balance system savings Stephen will be covering related to less wiring, combiner boxes, and there's benefits to the inverter. Initially, when you drive to a higher voltage, inverter costs tend to be higher because production is limited and all the components aren't available. But as soon as that becomes manufactured at scale, there's real benefits to the inverter. Inverter at first principles is a current limited device, so voltage is almost free, and you can leverage the power bridge assembly with a lot more power and really drive the cost down. We're seeing that, and also get higher yield through lower electrical losses. And so the image pictured here shows the one of the larger systems. It's a system over 300 megawatts using 1,500 volts. Stephen?
You bet. So here we wanted to show somewhat of a breakdown of what are the typical electrical E-BOS savings for a 1,500 volt system. Really, so we look at it, we're really looking at it by the item, the quantity, the cost per unit, the system cost, and then we'll look at the overall. But really, the PV ends up being, it really ends up being the same. So the DC feeder wiring, we believe, again, and we're speaking in general terms and averages here, but that certainly decreases the cost per unit. Really is the same, but ultimately the system cost, really goes down. The DC string wiring, again, the quantity goes down, the cost per unit stays the same, but the overall underlying theme here again is the system cost decreases. Combiners, while you have a decrease in quantity, because we've now gone to 1,500 volt and that architecture there, the cost goes up, but ultimately, the resulting is the system cost down. Again, similar with the inverters. And as we work through the labor, again, quantity less to install, cost per unit is the same, but the resulting system cost goes down. And again, with the tracker, as we kind of work through this, the quantity of the tracker, ultimately, at the end of the day, the quantities and the efficiencies of the installation result in a lower cost or savings. And I think that this is in general what the industry should see in the future as well. As we kind of look at, we wanted to really break this down into a block system. So what we've done here is we've identified a 1,000 volt versus a 1,500 volt layout. in these two layouts, we really wanted to keep the module rating the same, combiner boxes the same, and the PV home runs the same. But by going 1,500 volts, we can increase our inverter capacity, certainly increase our tracker length per inverter, as Dan was talking about, increase our DC capacity, and ultimately lower our losses. And the result, again, as you look at the numbers between the two, is ultimately the result is more energy. The other thing that we wanted to do is we really wanted to break this down into a project comparison. So as we look at a 125 megawatt reference project and really compare between the 1,000 and the 1,500 volt system, you can see the system size is the same, AC and DC. But with 1,500 volts, you see a 33% reduction there. Your inverters go down, your combiners go down, your trackers go down, the quantity of your strings go down, DC home run cable, and then of course your string wire, and the result is less quantities of materials to install. So you're also going to see labor efficiency there as well. Dan?
Thank you, Stephen. That was awesome deep dive. The way we really approached this is we wanted to have a standardized product. And essentially these utility projects are large, and so it's worth optimizing them. And so we have these systems that are at using string lengths of 28, 29, or 30 modules per string, which covers any meteorological climate zone in the world for working out when you work out the voltage and temperature characteristics. So what we started by productizing that, and 18 months ago, and then rolled this out and really leveraged the work we had done on the self-grounded tracker with the actual physical structure is the grounding element to save additional materials and installation. We leveraged our active stowing and torsional limiters, and we've been successful at getting these listed to UL 27 and 3703 and deploying over gigawatt. And the results have been really solid. We're seeing that there'd be no reason to go back. If it were my power plant, I'd certainly go to 1,500 volts and drive that. And we've seen a range of suppliers developed for other components, inverters, combiner boxes, fasteners. So there's been an ecosystem that's now supporting this. I find it extremely exciting for where we need to go to drive down the cost on this technology. And so what this looks like, physically, when you do the layouts, are these three tracker lengths. Again, 28 to 30 modules per string, and that allows a really nice layout in the field. And it can be really optimized to requirements by jurisdictions related to fire roads. Again, because our system does not have a drive running up the center, these can be spaced to allow a lot of flexibility on the sites where that serves as a road. You don't need to leave a road at the end. The systems can be washed as very efficiently as they are in the 1,000-volt system, where in the case of the NEXTracker system, we have a washing feature where a subfield of, say, 100 trackers, they can actually face each other for a brief period, and a truck can go through, and you can actually wash the left and the right side together because they're not impeded by that element, and they can move independently. and same for vegetation management. So we see the operational benefits nicely aligning with the labor savings and the increased yield by being able to rotate over to 60 degrees. Okay, so what does this mean in terms of the market? This is a great chart that GTM put together that really shows the growth of 1500-volt systems globally. And actually quite a bit of this was done by the projects that Stephen mentioned with us and Blattner in North America. We are focused on other regions as well. Asia Pacific, we're working on, we have orders for 1500-volt systems in other regions that we're working on. We really see the utility systems and tracker systems as the fastest growing area in solar. And, we support roof systems. Done a lot of those myself. They're awesome. But, these systems on the ground are just, it's hard to beat the numbers because the per unit cost of installation is lower and the productivity is just, outstanding, and they're very efficient to maintain. So the numbers on the utility scale and community solar systems are growing quite quickly. So we see this growing over time. And one thing I'd like to do is I'd like to jump back to one of the very early charts that Ben showed at the beginning of the presentation, because I find this fascinating. And it really talks to cost. When you look at the cost of solar, since I've been involved in the industry, at the very beginning, modules were about half, and everything else was about half. And so like in 1990, when we did the 650 kilowatt system, in that year it was $10 a watt. In today's dollars, it would be about $30 a watt. Modules were $5 a watt, and everything else was $5 a watt. And if you look, amazingly, at the Nellis project we did in 2007, that was also true. The system was $7 a watt, and the PV then was $350. Now look, here we are today. The modules are about half. Even with this crazy cost reduction we've seen in the solar panels in the last couple of quarters, everything else is about half, especially if you, ameliorate the soft costs associated with project development and stuff. So how is that possible? Because back in the day, a couple decades ago, we were thinking, well, gee, the PV is really a semiconductor thing, and that should have much higher costs, where the other stuff is commodities like with steel and so forth. Well, it's done through really fantastic engineering and product development by our whole industry. NEXTracker is part of, but others in the industry are driving this. In the electronic side on the inverters we spoke to, and other structures companies are driving great ideas. And so, in our case, we were able to use the fluid mechanics and now really pushing this 1500-volt system in order to significantly lower the cost. So we feel it's almost a duty and obligation on the tracker side to keep pace with the progress we've seen on the panel side. And so we really believe trackers are going to keep growing, maintain a share even as panel prices are decreasing. And another point we've been evangelizing for several decades is you really need a tracker when solar goes to scale, because customers use power over a broad spectrum of the day, not just in the middle of the day. And so the trackers really help with the duck curve and making power late in the afternoon. So we very much stand by GTM's market projection here. We think it's good. And where does it go from here? We've talked about up to 1,500. It's just coming in. No module manufacturers we're aware of or inverter guys are really pushing for higher than 1,500 right now. There's dielectric issues relative to the encapsulant EVA and, backsheets and so forth. However, what history showed is about every decade, we're going to see an uptick in voltage. And there's certainly no technical reason why it can't go further. So, if we were to pull out a crystal ball, we would certainly expect within 5 to 10 years, we're going to start seeing higher voltage. Now, even if today that doesn't look like it's a very large savings, by that point in time, the other components should have evolved enough that it should be. Okay, so that concludes the prepared remarks Stephen and I had, and I'll hand it off to Ben to MC the Q&A.
Thank you very much, Dan. And I want to thank NEXTracker and Blattner for being sponsors on this webinar. So with that, I'd like to move over to the formal Q&A portion of this webinar. As a reminder, you can continue submitting questions through the module to the right of your screen. We're already receiving great questions from the audience. Would really love to hear your feedback. So one really important question that's come in, gentlemen, is the following. Are all electrical suppliers for combiner boxes, breakers, switches, fuses, etc., are all these suppliers now on board with equipment tested for 1500 volt DC operations, or are there some outliers?
Well, I think it's important. I want to take a little bit of that because as we talk about the component landscape here, I think let's be honest, the component landscape here is critical to having a competitive marketplace. And so I think in terms of the landscape, in terms of what it looks like right now, there are 12 to 15 months ago, it looked pretty bleak. There just weren't many. But, I mean, you take the NEXTrackers, you take who are a pioneer in getting to 1500, you take Shoals, you take GE, SMA. I mean, some of these folks were, they were the ones who drove us here. And I think it's important that while not all of them are there, there's a lot there now today. And certainly we've got a great ecosystem to draw from. So if anybody's wondering whether or not the components are there, no, they're there. And it's only going to strengthen in time. But I think the point that I really wanted to make to the group, kind of curtailing off of the question, is it takes the suppliers and supply chain to drive us up and to the right and to continue to look for that next opportunity or advantage in this market, because frankly, we're competing against many other energy forms.
Great. Now, between a vendor and an EPC, as partners, how do you manage or kind of negotiate project technology or design decisions? I'd really love to, for both of you gentlemen, to kind of walk me through that process.
Stephen, if you want to start, then I'll be your wingman.
Yeah, I think really what it really comes down to in this industry is we need a little longer runway when we start talking about negotiating agreements. We need the developers actually to present a little longer runway of opportunities, and certainly I would venture to guess that all of our competitors, Blattner's competitors, would say the same thing, that in order to really get the most benefit, and to start that process, we need to know what's coming. It's hard for us to make commitments to the supply chain when, as an EPC, when we have no commitments from a client base. But I would say really to start that process off, it really comes down to taking a portfolio of projects and figuring out. And that's really what we did with NEXTracker. Was we really looked at the landscape and said, how can we get this accomplished? And you really just have to sit down and start, but you need the projects to get those conversations going. Dan?
Yeah, I'd certainly echo that. Some business models of some owners, they want to bid every project out, and there's nothing wrong with that. But I think the partnership model and it really starts with the end customer and the developer. If they have a portfolio of projects that are coming over time, what they can do is work with the EPC, and the EPC can work with their partners to really have more visibility in terms of the and stability in terms of the volumes. And what this allows, in our case, us to do is go upstream to the steel mills and other folks that we're working with, and it really starts there. So on the one end, you have the developers and the long-term owners, and on the other end, you have like the most basic raw materials. And so it helps us to be able to insulate customers from things like commodity risk. The commodities, if you go look at the price of copper or steel or some of these other commodities, I mean, it's kind of like, being in Las Vegas. You're not sure what's going to happen in the future. And so by having more certainty in demand, we can work with our suppliers to, one, help lower costs, and two, remove risk. And then memorialize those benefits in the form of a master supply agreement, because think about it, the developer is bidding perhaps they're looking for an offtake agreement with the utility. They can't go back to the utility and say, hey, I need the higher price because steel bumped up or what have you. Similarly, the EPC, can't go to them and do that. And, so it's a three-dimensional problem. And really the best way to solve it is to have, a longer-term model. And that's worked out really well over my career with a number of partners. And a lot of it's based on, relationships, and you lay out a plan. And as new technology comes in, you may not be sure what kind of solar panel is going to be there. You can do parametric analysis to say, well, if the efficiency goes up, you should get the benefit of that. Or if new technology is available, that should be to the benefit. We're all really pulling in the same direction here in this industry, which is really accelerating the transition from coal and other dirty fuels, to renewable power. And the growth in the industry has vastly exceeded, my expectations through at any given point. And so that's having these partnerships and longer-term view from the developer all the way through the raw material supplier are what's going to be key to us maintaining ongoing cost reduction in solar.
Now, for this to be kind of economical, are there any particular size constraints for systems, either for NEXTracker single-axis tracking solutions or for 1500 volts? Or is this a one-size-fits-all highly economical solution?
I'll jump in if I may, Stephen, and then please add. So when we developed the original NEXTracker system, we wanted I'm a huge believer in distributed generation and community solar. From the beginning of our careers, we really saw a lot of benefit to that because you can support the grid with more, and in this context, I'm talking about systems, a megawatt to 10 megawatts or 20 megawatts. And so we really, one of the reasons we developed this individual row tracker was to be able to support those projects and irregular project sites and so forth. So there's no fundamental limitation on the tracker or at 1500 volts. You're on the edge a little bit, with some of the customers. If it's a utility customer, no problem, or if it's a behind the fence customer, no problem. If it tends to be a system that's maybe owned by a wastewater treatment facility or something like that, you'd have to work with the jurisdictions. And this is the point where Stephen has more current knowledge and expertise than myself. So Stephen, what are your views on that as we roll it out in smaller size projects?
Well, certainly, I think that as we're certainly seeing these projects become more land constrained, so we see the market, and of course I think that the market, with the advent of certainly DGs playing a big part. You've got residential, but when we think about utility, I think the days of the 300 or the 500 megawatt facility are coming to an end. Now there certainly will be some of those out there, but I think we have to continue to figure out how to put more into a smaller box in a sense, and that's again I go back to the components and that ecosystem. We have to continue to find more efficient ways and means of getting there. The land does become a constraint. It is a constraint, and the utilities they're not buying big bunches. They want to buy where the need is, and that's where DG fits really. Is you're able to put a system where you need it, and certainly we're seeing the industry gravitate to that, down that path.
Yeah, and as I'm thinking about it, we run in the DG side over 100 projects, and those are 1,000 volts every one of them. And so as I'm thinking about it, it's like, well, we have the UL 2703 and 3703, so actually I don't think it's an issue. I can't think of why it would be an issue rolling that out in any given jurisdiction. So I think after chewing on it for a minute here, I'd say my answer would be no. There's no problem rolling it out in smaller projects.
So how do you approach AHJs to discuss 1500 volt systems?
I would say that
having the list. Oh, go ahead, Stephen, please.
Well, I think that certainly the discussion goes a lot better when you have when you have all of the 1500 volt components UL listed, and they're very recognizable. They're widely adopted, or they're adopted out in the industry. That discussion goes a lot better. We haven't seen any pushback with respect to AHJs and 1500 volts.
Okay, great.
Dan, any thoughts?
So what kind of issues have you seen with either monitoring or SCADA with the adoption of 1500 volts? Have there been any issues?
I would probably ask
with respect to NEXTracker. With respect to NEXTracker, there's no difference. We're still collecting all the data we did at 1,000 volts.
And so this presentation, we've been talking about the adoption of 1500 volts in the United States. Have there been any sort of obstacles or bottlenecks globally for adoption of this system architecture that you can speak of, Dan?
No, to the contrary. I think we owed Europe thanks for helping drive this, first on the 1,000 and then on the 1,500. And we're seeing our first 1,500 volt systems now going in Asia that we're involved with, and helping drive that. And I think folks everywhere really want the same thing. They want more cost-effective solar energy, and we're in a global race against coal. I mean, when we're doing stuff, in India and other places, we need to redouble our efforts as an industry and support that, because we don't want the build-out to be with a big coal fleet like the initial build-out in the U.S. and China was, right? So we're solving that now in the U.S., but, we have an opportunity to really get there. So everyone wants the same thing. And, now that this is proven, in Europe and the States, everyone's migrating there, and now we're seeing inverters available in some of these other regions at these higher voltages.
So this is a question for
And modules.
both of you. Have you heard of any challenges getting 1500-volt projects financed, or has the financial community viewed these projects with the same sort of perspective as 1000-volt projects?
You know, this is Stephen speaking, but from our perspective, we have not. So I would not. We tend to hear about those things, but certainly we have not heard where there's a struggle getting 1500-volt financed.
Same with us. I think the key is, you know, doing your homework, getting the certifications and so forth done. And when you have that and the testing done, that's gone smoothly from NEXTracker's standpoint.
So there's been a lot of great questions today, but it's unfortunately 2:57 here on the East Coast. So we're just going to have time for one more question, unfortunately. So how is string inverter integration into the tracker design being considered? And that goes for you, Stephen. First.
Well, that might actually be a better question for Dan, frankly, because I really believe Dan's got a solution there.
Well, first of all, I think the whole string inverter developments are super interesting, and a lot of folks are studying that really hard. We've got some great manufacturers out there pushing that really hard. We developed actually an integrated string inverter that it actually hangs on the tracker. It's part of the tracker, so doesn't require a separate skid. That could be either 1000 or 1500. We've done 1000. We haven't done 1500, but we could. I think, however, on the 1500, and folks are doing string inverters at 1500, I think the lion's share of the benefit on the electrical savings is actually the DC home runs get lower. And when Stephen covered the electrical balance system cost area, I mean, those are some big numbers. And so if you're putting an inverter, a little string inverter anyway on each row, you know, essentially what would happen, like in our case, is you'd go from, you know, 4 strings to 3 strings, so you'd save like one little home run on each tracker. So it's not that big of a deal. I think what would be interesting is if the DC voltage, the 1500 volt, reflected to a higher AC voltage on the output of the inverter, because that's where you get hurt on the string inverter, where, you know, you have to aggregate more of those. You know, if it's at 480 volts, for example, that's just a lot more to aggregate. But if that was helpful, reflected back with a higher AC voltage, then that could be helpful. So in summary, we see there's a benefit, but it's not nearly as big as the benefit on utility scale, or let's just say central inverter systems that you get when you go to 1500 volts.
Well, great. Well, thank you so much, and that brings us to the end of today's presentation. I'd like to once again thank our sponsors for this webinar, NEXTracker and Blattner, for making this discussion we just heard possible. This presentation will be available on demand for 3 months on the GTM website, so please share with your colleagues and feel free to rewatch at any time. Thank you for joining us today, and I look forward to seeing you again soon on the next GTM webinar. Thank you.